Hello everyone, welcome back to Code Konyo. So for today, I am going to continue discussing about recursion. As you can see right here in our program, I have here a an implementation of a looping or repetition using for loop to get the summation of natural numbers based on the value of n. So right here, it is going to return the sum or the sum value based on the looping, based on for loop, which is whatever the value of n, it's going to like it's going to add the numbers, that number from one through the value, through its value. Let's say one, and then let's say we have here five, and it's going to get the sum from one through five. So one plus two plus three plus four plus five, which is actually 15, and we can actually do it like uh, call it there. So recurse that, let's say sum of natural numbers. Let's say we have five, and this will give us a 15 value. Now, uh, it is believed that alternately, anything that can be solved through a recursion can be also, anything that can be solved through a looping or a repetition can also be solved the, via a recursion. So recursion can help to simplify the implementation of some complicated problems by making the code clearer and more readable. But it has also been said by most of the programmers that recursion or recursive approach often requires more memory as the stack memory required increases such with each recursive call. However, it has also been said that using recursion sometimes, or using recursive approach sometimes, is going to help the program increase its efficiency and more likely to have less time complexity in our algorithm. So we're going to now implement this sum of natural numbers in a recursion or recursive method approach. So we're just going to have or to copy this one. So let's copy this one or overload this method right here. So let's make it like rec. And then after that, we'll have here a condition. So just allow me to finish it. So if n is greater than or equal to 1, and then this is going to return the sum of natural numbers, and then we're going to decrement the value of the n by deducting or subtracting minus 1, and then we'll have here, and every time it is going to call that recursive function, it's going to add the with the value by with the value of n, and then here we're going to have return n. So as you can see in our program or in our recursive method, there are uh, two main requirements in a recursive function. The first one is the stop condition, and the second one is the recursive call. So this one is the stop condition. Okay. So the idea of stop condition is it is actually a function or a statement that returns a value when a certain condition is satisfied without further recursive call. So it's not going to repeat the execution of that method. So the other one is the recursive call. So this one is the recursive call. When we talk about recursive call, this is a part of the joke. This is a function calls itself in which an input is step closer to the stop condition. So that's recursive call, and that makes uh, the execution of a method repeatedly executed. All right. So we're going to run this one, and we'll see if we are able to come up with the same output. So right here, so we have here rect, and then you have here 15, and if you're going to have here like 10, like 10. So you have here, okay, the same value. So this is via a loop, and this is via recursion. Okay, so as you can see, of course, in terms of calculating the time complexity, we have here a lot of variables used compared to recursion. So the more variables you're going to use, the more it is going to not going to save our memory, the space of our memory, and even the execution, the time it is required to execute compared with our recursion. So I guess that's it for today. Thank you guys for watching this video. Have a great day ahead, and bye bye.